Okay, I think I've got things in the right place now. I made some mistakes, and then I made additional mistakes. And just looking at things and writing down numbers that didn't correspond. So, the initial problem as posed is a valid problem. You don't have too much information. You don't have too little. You just have to assemble it carefully. I would have been much better off to write down M1 times U1x minus V1x equals negative of M2 times U2x minus V2x. And then carefully plugged in the relevant numbers. Okay, in any case, again, this is a continuation of something, but this could stand alone. We have 6 kilograms moving at 12 meters per second at 53 degrees. Imagine 53 degrees about like this, moving at 12 meters per second. Something else moving at almost the same speed hits it, resulting in a velocity of 4 meters per second at 133 degrees. Okay, so that'd be like 4 meters per second in this direction, so much slower. Well, your x velocity changes from this to maybe this. At what angle does this thing have to hit it to make that happen? Well, it's got to be coming toward it. So we know that the velocity of the second, we're not given the angle of the velocity of the second, we just know how fast it's going. It's got to be coming in this direction. And it's got to carry enough momentum to slow down and reverse the direction of the first mass. Okay? So we can start thinking through what that looks like, what that feels like, so we can kind of relate that to the equations. We also know then that after collision, the second object is moving at 5 meters per second. That tells us something about how solid the collision might have been, and combined with what we can think about here, gives us at least some insight into what's going on. We're not likely to solve this problem by intuition, by insight though. We can understand why the solution is what it is, but we really have to use the principles of impulse momentum, conservation of momentum, the fact that equal and opposite impulses will give us equal and opposite changes in momentum, momentum being a vector quantity, that's going to give us equal and opposite changes in the momentum in each of our independent directions. Okay, so we take what information we have, and we get our U1, our after collision velocity of the first 6 kilogram object. It's 4 meters per second at 130, I'm sorry. I'm not even sure what I was saying there, but let's go back. We take V1 and we break it into its components. And that's very straightforward using the sine and cosine. And we also note that, well, we take V2 next. Okay, so we're looking at before collision quantities. V2 is 10 meters per second. We don't know what V2x and V2y are. We're not given any information at all except how this thing interacts with the first, with the first object. But we do know by the Pythagorean theorem that the sum of the squares, square root of the sum of the squares of the components is equal to the speed. So we're given the speed, we can write this. That's an equation that relates V2x and V2y. We're going to have to use that. If you look forward, look ahead a little bit, you see we're going to have 4 unknowns here. And that's 2 of them. And the other 2 are the x and y components of U2. Okay? And by the Pythagorean identity, we see that the square root of U2x squared plus U2y squared has to be the speed of U2. U1, we are given the full information. We get U1x and U1y. Now it's very straightforward to plug in, and I say it's very straightforward. I tried it 3 times before I got it right, but like I said, not a great morning. Just, yeah, nothing really going on, but yeah, weather, snow scheduling stuff. Okay, so we have the 6 kilograms times u1x minus v1x, the change in velocity of the first object. Okay, and v1x is 9.6 meters per second. And that's equal and opposite to the change in momentum and the change in the x momentum of the other mass, the 10 kilogram mass, and its change in velocity is u2x minus v2x. We've got the negative sign there because this change in momentum should be equal and opposite to this change in momentum. We have our Pythagorean identity for the first object, for the after collision, for the before collision velocity of the second object. We have this here. And I squared both sides, but it's the same identity. And then we plug in similar y quantities. Let's make sure we got them right. We don't know u1y, we do know u1x, which is negative v1x, which is your 7.2. We're doing the y, it's not x. Okay. This is the y momentum, doing u1y minus v1y, okay? The y component of the first object before collision and the y component of the velocity of the first object after collision. Okay, and we don't know u2y or v2y, so here's our change in the y momentum in parentheses of the second object, and that's got to be equal and opposite to the change in y momentum of the first object. So we also have this equation that I didn't have room to write down here. Having messed up a lot of things, I just went ahead and rewrote them in a better color. I'm not sure that's a better color. Chalk's a little hard to write with, but I kind of like the color. Okay, so we just rewrite all these equations. Okay, these 3 equations plus this one where we square both sides. And we see that we now have 1, 2, 3, 4 unknowns. Okay, u2x, v2x, u2y, v2y. Now that's 4 unknowns. It's a good thing we have more than these 2 equations. We need these 2 equations as well. Now, solving these equations gets pretty hairy algebraically because these things are squared. It's not nice linear equation. We don't have nice linear equations. But we dive in and just keep our wits about us and do the solution. On a test, setting up these equations would be half the problem, solving probably the other half. Challenging, a little bit of, the algebra's a bit challenging there. Okay, so again, now in the previous examples, we were given nice rectangular information. We were given the before and after collision components of all the velocities, or a sufficient number of velocities to easily find the before and after components that we don't know. Here we have to do a little more work. We have to think just a little harder about it.